Welcome back to part 2 of chapter 4 section 7. Hopefully this will be the last video for this lesson. It involves absolute value and distance when working with the coordinate planes. Now, as promised, it's time for you to pause the video and work this problem on your own, and then we'll come back and see what the answers are. Make sure you're giving me good quality supporting work just like I've been showing you. Alright, let's take a look at how I'm going to solve this one. First, I'm going to take and I'm going to find the coordinate planes of each point. So point N is going to be located where X is going to be negative. Let's see, how do we have these? We have this in tenths, so 1/10, 2/10, 3/10. So it's going to be X value is going to be negative 0.1 or 1/10, and my Y value is going to be a positive 1/10. Meanwhile, my M value is going to be at a positive 1, 2, 3, 4/10, so it's going to be positive 0.4, and my Y value is going to be a 0.1. And don't know what happened right there. That should not have been listed that way, so hold on. I think my auto shape got me on that one. Now, what do we notice? We notice that our Y values are the same. Since our Y values are the same, we are going to focus all of our love and attention on the X values. So the absolute value of negative 0.1 is going to be 0.1. The absolute value of 0.4 is going to be 0.4. And since these points are in different quadrants, we're going to add those numbers together. 0.1 plus 0.4 is going to give us a 0.5 for our final answer. So how far apart are the units going to be? They're going to be 0.5 units apart, and our answer checks. It's that simple. Now, I should add that this is showing your work. I identified the coordinates of each of my points. I found the absolute values of the parts I needed, and then I showed my addition. So I had 3 different steps of supporting work here in order to justify the answer that I came up with. Make sure you are giving me good supporting work in your homework as well. Now we're going to find the vertical distance, which is going to be pretty much the same thing.
When 2 points are in the same quadrant, and they have the same x-coordinate value, use the absolute value of the y-coordinates to find the distance between the 2 points. The absolute value of each y-coordinate will give the distance from the point to the x-axis. The absolute value of negative 1 is 1, and the absolute value of negative 5 is 5. Subtract the absolute values of the y-coordinates to find the distance. 5 minus 1 equals 4. So the distance between the 2 points is 4 units. When 2 points are in different quadrants, and they have the same x-coordinate value, use the absolute value of the y-coordinates to find the distance between the 2 points. The absolute value of each y-coordinate will give the distance from the point to the x-axis. The absolute value of negative 4 is 4, and the absolute value of 1 is 1. Add the absolute values of the y-coordinates to find the distance. 4 plus 1 equals 5. So the distance between the 2 points is 5 units.
Alrighty then, how about put me to sleep, but we got through it. So let's find the vertical distance between point D, which is located at negative 1, negative 1/2, and point C, which is located at negative 1, negative 2. Think about it. Are your x-coordinates the same or different? They're the same. Are the y-coordinates the same or different? They're different. So which one are you going to work with? You're going to work with your y-coordinates. But we need to figure out, are we going to add them or are we going to subtract them? And the answer to that depends on whether or not we're dealing with the same quadrant. Now, if you take a look, the x-coordinates of both values are going to be negative, so they're going to be in the same general direction, general half of the coordinate plane for the x-axis. The y-coordinates, well, they're also both going to be negative, and because both your x and your y have the same values, you know it's going to be in the same quadrant. In this case, if they're all negative, they're all going to land in quadrant 3. That means that we can use the subtraction approach because they are going to all be in the same quadrant. So from here we can say the absolute value of negative 1/2, that negative 1/2 came from D's y value right here. So we're going to say the absolute value of negative 1/2 is going to be positive 1/2. The absolute value of negative 2, well, that is going to be a positive 2. And then from there, check that. That works. Now all we have to do is subtract those numbers because they are in the same quadrant. We use subtraction. 2 minus 1/2 gives you a value of 1 and 1/2 left. So the distance between our 2 points is going to be 1 and 1/2 units apart. That's all there is to it. If your 2 points are in the same quadrant, you use subtraction. Easy math. And now it's going to be your turn to pause the video and solve a problem involving vertical distances between 2 points that are located in the same quadrant. And it's almost there. Still almost there. There's the 2 points you're going to work between. Do that problem. Give me good quality supporting work. Alright, let's take a look at the problem. Now, first thing I want to point out is that on this problem, let me get my pen working here. On this problem, our x values are going to be the same. They're both 1. So we need to find the distance between the y values. One y value is 1, and the absolute value of 1 is 1. The other y value is 1/4, and the absolute value of 1/4 is 1/4. And from here, all we have to do is subtract 1/4 from 1. That means you're doing 4/4 minus 1/4 equals 3/4 for your final answer. This is showing your work. Yes, you still have to show me the absolute value of the positive numbers as well. This is showing your work. If I see anything less on each and every one of the problems, you will have done them just for fun. Type in our answer here. It is a fractional version of 3/4. Accept and check, and our problem checks. Now we're going to look at finding the vertical distance. The vertical distance between points of 1 and 0.5 and 1 and negative 0.5. And this time you've got 2 points that are in different quadrants. You know they're in different quadrants because the signs of at least one of the values, the x or the y's, are different. In this case, your y values have different signs, therefore you know that they're going to be located in different quadrants. So we can say here that our x coordinates, they have the same sign, they're both positives. However, your y coordinates have different signs. There's going to have one of them is going to be a positive, one of them is going to be a negative, and because of that, we know that they're going to locate in different quadrants, just like I said they were. From here, moving on to our next value, the absolute value of 0.5, that is going to be the y value for point S, is going to be 0.5. The absolute value for negative 0.5, which is a y value for point T, is also going to be 0.5. And from here, because they're in different quadrants, we're going to add them together. 0.5 plus 0.5 is going to be 1. Check it. So the distance between point T and point S is going to be 1 unit apart. Yes, it really is this simple doing these problems. Now, can you do it? Let's find out. You pause the video and work this problem on your own. Check your answer and see if you can make it happen. Did you get it done? Alright, my turn. First thing I'm going to notice that this value here and this value here, my two x values, are going to be the same. They're also going to be positive. That means I need to focus on my y's. Now when I look at my y values, I'm going to notice that that one is going to be positive and that one is going to be negative. Because those have different signs, we know that it's going to be located in different quadrants. Because they're located in different quadrants, that means we're going to be adding their absolute values. So let's start off with the first one, the 0.4. The absolute value of 0.4 is going to be 0.4. The absolute value of negative 0.8 is going to be 0.8. And when you add 0.4 plus 0.8 together, what do you get? You get 1.2. So the distance is going to be 1.2 units. We'll go back to our problem. 1.2 units. Check our answer. Everything checks. Don't make mistakes though. This is showing your work. I've showed you where I changed my absolute value, found the absolute value of each number, and then I added the numbers up because they were in different quadrants for use addition. Make sure you were giving me good quality supporting work on your homework. And now we're going to look at some real-world problems involving distance on the coordinate plane.
Fritz and Manolo like to skateboard together at a nearby park. They want to determine who has to walk the farther distance to get to the park. So they graph the locations on a coordinate plane, with the city's main square at the origin. Each whole unit represents a city block. Fritz's house is located at the point -2.5, 2. Manolo's house is located at the point 3, -3 3/4. The park is located at the point 3, 2. Who has to walk the farther distance to get to the park?
Alright, well let's take a look at that. That doesn't look too hard at all. What we're going to need to do is, when we're solving this, so what's our approach going to be? My approach is going to be, I'm going to find out how far it is from Fritz's house to the park, and then I'm going to find out how far it is from Manolo's house to the park, and then after that, all we have to do is see whose is going to be the greater distance. So, let's start off with a good screenshot to work with here, and I'll come back to you in a second. Now the first thing I want to do is I want to compare Fritz's house to the park. And when I compare, I'm going to do these in blue, and you can see that the blue shows that my my y values are going to be the same, so I'm going to concentrate on my x values. My x values are going to be one's positives, one's negative. That means that I'm going to have to add the absolute values. So for Fritz's house, I'm going to say the absolute value of -2 1/2 is going to be a positive 2 1/2, and the absolute value of 3 is going to be a positive 3. And then I'm going to take 2 1/2 plus 3, and that is going to give me, whoops, wrote the wrong thing there. That is going to give me 5 1/2 is going to be the distance from Fritz's house to the park. Now I'm going to change my color to red here, and I'm going to focus on Manolo's house to the park. And first thing I'm going to notice is that on Manolo's house, both of my x values are going to be the same. So I need to focus on my y values for the distance. On the distance, one of them is going to be negative, one of them is going to be positive. That tells me I'm dealing with different quadrants, and once again, since I'm dealing with different quadrants, I have to add the absolute values. So for Manolo, the absolute value of negative, whoops, wrote that wrong, 3 3/4 is going to be a positive 3 3/4. And the absolute value of 2, well, that's going to end up being 2. So now, because once again they were in different quadrants, we're going to add those. 3 3/4 plus 2 is going to give me 5 3/4. Which one of those values is going to be bigger? The 5 3/4 is. That means, going back to our problem, that Manolo has a longer walk to get to the skateboard park. That is going to be it for this lesson. Make sure that you give me some really good, high quality supporting work as you go through your assignment, because if all you're doing is throwing down answers, I have to give you an incomplete until you can prove it to me using work that looks an awful lot like my work I'm giving you here, showing where my absolute values are coming from, showing what I'm adding together after I find the absolute values, and then getting the final answers. Good luck on your homework.